We're going to look at the laws of logarithms and start with the first law of logs. Now I can write 8 in a different way, as a product of two numbers. That's the important thing. I've written the argument of the logarithm as a product. This invokes or allows me to invoke the first law of logs, where this product can be broken up into the addition of two other logs. It's this law is easy, but it's easy to get wrong. So just to demonstrate the biggest sort of mistake that I see, it might be tempting if you ever saw this. To write this, and you would be dead wrong. Because the law of logs is all about adding, not multiplying logs. So here we are adding logs. It's the argument of the log that we write as a product. So I'm just alerting you to where the biggest error is that people make. Now you've got to be able to go, this probably, is sometimes it's useful to write it in a different way. But perhaps this is the format that you're more used to when you are adding two logs and in turn asked to simplify them. So we're adding two logs so we can see that we can use the first law to multiply them, and finally we can simplify. But always be aware that if you're given just a straightforward log, it may suit me to write it as a product of two numbers and in turn write it out in what you might think is a more complicated way. I've started off with just this one log and I've ended up with two logs, but there are situations where this is useful. I'm just going to draw your attention to a couple of things. If you were to attempt to simplify this, again you'd be dead wrong. The laws only apply to logs of the same base. This is a base 4, whereas this is a base 2. So you cannot apply the first law of logs here. However, later on you will see that you can change the base of logs. So you would change either both of these to a base 2 or both of these to a base 4. Then you could apply the first law of logs. The other thing is here, you might see that we are adding two logs. They're the same base, and you might be tempted to write 2 log 8, and again you'd be dead wrong. The law of logs is about adding log something plus log something, not 2 log, 3 log, a half log something. It's got to just be just log something, add log something, no coefficients. Again, very shortly we're going to see how we would deal with that. So here we have log 8 to the base 2, and we're going to talk about the third law. The second law I should say. We can write 8 in a different way as 16 over 2. We're now talking that the argument is a quotient, and that allows us to invoke the second law, where we will write it out as two separate logs, subtraction. Again, I'm just going to draw your attention to, again, if people are going to make the error, it's going to be this. And they think that we can write this, which of course is dead wrong. We subtract logs, and we're talking about dividing, the quotient of the argument of the log. So just to draw your attention to that, easy to get right, easy to get wrong if you're not clear about the laws. But again, you're probably more used to going the other way when we've got 2 logs that we're subtracting. They are the same base, and so we can invoke that second law to write them out as a quotient, and then we can simplify. So of course we've come on now to the third law of logs, and when we have taken the power here, we just bring it round to the front. So this is exactly the same as 2 log 8. Dead easy for me to show on this because it's a good visual tool. That's all I'm doing, moving it around to the front. This is particularly useful because we've talked about we can't use rules 1 and 2 when we've got something in front of the log, and so it's dead easy for us just to take it across and make it the power here. And of course, I can easily simplify this like that. Of course, you may need, for some reason, a bit of intuition to see that I can write this in a different way. Still 81, just written in a different way, but I've done this because then now it allows me to move this around and write it out as 2 log 9 to the 9. Indeed, I'm just thinking, is there another way I could write it out? 3 to the 4. 3 threes are 9, another times 3 is 27, times 2 again is 81. So in the end, I can write this out as 4 log 9 to the 3. The same thing written in a different way. And you might want to use your calculator just to check that this is indeed true. So this is a question that I mentioned earlier. We can't use the first law of logs because it's just got to be log on its own that we're adding. Log something, add log something. But we can use the third law of logs. We'll bring that 2 around. I can simplify. Now I can use the first law of logs, where if I add 2 logs, it's the same as multiplying them. And simplify. And again, you may well want to type this into your calculator and just check that I have indeed simplified. I'm just going to mention this as sort of special case that's worth noting, that crops up frequently. I can write out a half, and again it requires good use of your knowledge of indices, instead as 2 to the minus 1. And now, having written it out in a form with an index, I can bring that minus 1 round to the front. In other words, I'll just make sure I put the bases in there. And this is something that you need to be on the lookout for. So if we've got, I think the general rule is something like this. In fact, it isn't. It's the same as minus log x. Nothing clever here. It's just I've written down the results. We've done it from first principles here. We've seen 1 over x. We've got a half. We've written it out as 2 to the minus 1. So we bring the minus across and we get minus log to the 2. And you can see there, this is just a straight through result of what we've done. And that's it.